So that's the other thing to keep in mind, is if you are going to go down the road of retraining, you would just have the output by the time you finish. All right, so Peter took all the data, he built the instruments. The nanostructure work was done with Lisa's lab at UCSD and a postdoc in her lab, Tamal, who's now at Zurich. And then Ayush and Steve were the collaborators on the physically motivated reconstruction. Ayush wrote the code, and Peter took all the data for that. There's a bunch of papers here that I put QR codes up for. So this is the spatial light modulator work. This is the optimization work. And then we develop in the open, so we don't IP patent anything. And so everything's on GitHub, all warts and everything. It's all free. We answer tons of people's questions. Lots of people have adapted the spatial light modulator code to get there. So I'll stop there. Thank you.
Thank you. So I know it's past time, but please ask questions if you have questions. You can leave if you don't have, but yeah, the speakers will be here, but yeah, please ask questions.
So, I understand it's iterative. So how are you constraining it? Are you looking at residuals so that it doesn't run completely off the rails?
It's the full likelihood. So what we ask is, what we have is a model, right? And so when we run the model, we then ask, how likely is the model to produce the data that we observed, right? And then the prior there, which is what is the constraint, is a prior over the noise. And in fact, we set that to be incredibly broad. And what we do is the solver uses something called a no U-turn Gibbs solver. So it's a special type of Monte Carlo solver that tends to not get off in these bad regions. And so we try to put as few sort of restrictions on there other than the fact that we have some guess at the noise parameters and we have some guess at the photon and the NA. That's it, yeah.
But basically you're constraining the Monte Carlo.
Yeah, but much broader than you would think. Yeah, so it's really driven by the physics is what constrains it. Yeah, so, yeah.
All right, thanks.
This sounds like a lot of computation, so how fast can you?
I mean, the images I show here run in like on a laptop in an hour or something. If you use a big computer, you can do like full 2048 by 2048 in a couple hours. Yeah, so it's not fast right now. I'm not trying to hide that at all. Okay. It's an idea that we're sort of hoping to push forward in the future. Yeah, so.
If you don't have any other questions, let's thank again the speakers and.
Mostly movies.